Hey, Jody here. For this video, I'm at JD Brewer's shop and we're comparing short circuit MIG to dual shield flux core. So this is really intended to be a conversation starter because I think there's a whole lot of people out there that aren't aware of the benefits of dual shield and they're still doing short circuit MIG when maybe they should give dual shield flux core a try. So we did kind of a race here, and you can see JD's kind of twiddling his thumbs there while I'm still welding. We'll show that in detail here along with some arc shots and the technique used for each process. So this is a 1 foot long T-joint, 1/4 inch thick metal, 2 separate joints so we're not heating up the one member too much and getting false results. And so this is the dual shield, only using 0.35 diameter today, just trying to keep the two diameters of wire the same. Would definitely choose a thicker diameter, 0.45 at least, maybe even 0.52 for this, but just trying to keep everything the same and mainly the amperage the same. So both joints are done at about 127 amps. And you can see very little manipulation is required on the dual shield. In fact, you don't even have to do that. You can just drag it straight up. 127 amps, 22.7 volts. You can see JD's kind of taking the lead there with the dual shield. This is the technique for the short circuit MIG that I use. I find that I have to do quite a bit of manipulation to get a fillet weld vertical uphill to lay down flat. And again, we settled out at about 127 amps, 18.5 volts on the bare wire. And this is the technique that I use for that. It's sort of a little series of overlapping triangles. Not really pausing at any one point. I'm just really tracing the front edge of that puddle, then coming straight across and then tracing the front edge of the puddle again. It works really good for getting penetration. It's a little bit slow and you wind up having to make maybe sometimes a little bit larger fillet weld than you need or would otherwise even want. This is 1/4 inch metal. Oftentimes the fillet weld size for this thickness would be more like 3/16. So I'm kind of, in a way, you could say I'm over welding it by having to go wider, and JD is making more progress because he's not having to do much manipulation at all. It's still progressing along at a fairly slow pace because of the small diameter wire size on the dual shield. He would, like I said, he would more than likely use 0.45 or larger for this joint otherwise, but we're just trying to keep the wire sizes the same to not skew the results too much. So he's just about done with his, and I'm only 3/4 of the way finished with mine, and you can see why. I'm really having to make a lot more manipulation. That makes my overall speed of progression much slower. Still a good weld though. You know, it's just rather quite slow. As I'm watching it here, I'm thinking, wow, that's really progressing along really slow. Now we did use C25 gas for both of these setups. Same exact machine. You know, the only thing we really had to change out were the drive rollers for the dual shield flux core. So we used knurled drive rollers for that and then change the spool of wire out. And that's really all you have to do when you're changing over to dual shield usually. It's a really quick swap out and there's a lot of benefits to be gained. So I'm talking here so it won't seem like it takes so long for me to finish this joint out. But man, seems like it's just creeping along here that last inch or so. So there's the dual shield, got a nice little peeler there. And again, this was set much lower and much colder than we would normally weld this thickness of a T-joint. Even with this diameter wire, it's got a big wide range. We could have gone way hotter, way faster and increased the travel speed, and I'll show a little bit of that in just a minute. So this is the short circuit MIG. This took right at 3 minutes. The dual shield took just a little over 2 minutes to do, and they both look, you know, decent, I suppose. But let's just see what they look like on the penetration side. We'll do a quick cut, polish, and etch here. And right away, the thing that jumps out at you is just, you know, I kind of over welded the short circuit MIG side. Generally speaking, the code books would call out for probably 3/16 minimum leg size here, and so I didn't have any trouble, you know, getting that. That's for sure. With the short circuit MIG, I went way over that, but even the dual shield, even as small as it appears, it's still way over the minimum. But let's weld a little bit at 500 inches a minute now. That's bumping it up from 335 inches a minute to 500. Still lay down pretty flat, still not hard to control the puddle. That's a big increase in wire feed speed. This machine goes up to all the way to 800 inches a minute. I wonder if it will do that. And we found out that it will. That's a wide range of wire feed speed. That's got to look like it's driving it halfway through the metal. Yeah.
Yeah, it's in there.
Now, I didn't get to do a cut and etch on this 800 inches a minute piece, but I will in future videos. Just wanted to get a good conversation started about dual shield versus short circuit. This is JD. This is my friend JD Brewer. He's got a YouTube channel as well called JD Brewer. This is my friend JD Brewer. He's got a YouTube channel as well called JD Brewer. He's a business owner. Anything he can do to save time, whether it's time welding or time not having to prep metal as much, is kind of a big deal. So dual shield flux core, I know you love it. So give us a few reasons why.
The number one biggest thing, which was you saw in the video, was the speed. It's faster. I don't have all the time to be sitting around making welds. I get paid for the job. If I could speed up any step in the job, that's always a bonus. And so dual shield's just straight up faster than hardwire, especially out of position.
I was welding with the hardwire. JD was welding with the dual shield. I was sort of jumping through hoops compared to what he was doing. I was making all these little loops because maybe somebody else can do it, but I've never been able to run a short circuit MIG uphill with no manipulation without it being really crowned up. So the dual shield just lets you basically almost run hardly any manipulation. You don't have to do any. You can run overhead, vertical, horizontal, flat, just a straight drag, push, pull, straight 90 degrees. It's very forgiving, it's very robust, and it burns through mill scale a lot better than short circuit MIG. So that all that added up means somebody in business for themselves, like JD, that's a time saver. Time is money, right? So you don't have time to clean up, 1,000 foot of stair tread prior to welding, you know?
Yeah, the main reasons we covered in this video, we showed how fast it is compared to hardwire MIG, how easy it is to weld out of position, and we didn't really show it in this, but you can weld over mill scale in it, light mill scale. Yeah, dual shield's my favorite for production and strength.
All right, well, that was a conversation starter. It's never apples and apples when you're comparing one process to another, because you could say, well, you didn't use the same wire feed speed, it's different settings and all that. I think dual shield flux core is one of those things that is ignored a lot by people who could really benefit from it. So if you're like a light fabricator and you're working on eighth wall tubing, you probably don't ever want to use it. But once you get on up to 3/16 and above, and the stuff got mill scale on it, and it's heavy and it's going to be holding a lot of weight, there's a point at which I think you want to consider getting rid of the short circuit MIG and maybe trying dual shield flux core. Not getting rid of it, same machine. All you got to do is swap out the wire and drive rollers, so it's an easy swap out. I'm talking too much. Hey, leave your comments below and stuff that you want to see us do with these machines. Also going to be putting that smaller Rebel to the test here in the coming weeks. And JD's got a big job coming up, so we got all kinds of things that we can throw at these machines. So I appreciate you watching. Hope you learned something. I'm always learning. And thanks, JD, for letting me work with you today. See you next time.